4.5, here we go. So 1 is isotopes. Then we do a bunch of questions that we've had other days. So 2 is AMUs, 3 is carbon 12, 4 is 12 AMUs, 5 is Dalton, 6, we say this for the last time until the test. It's about time for this to go away. It saves us a little bit of space and time on the quiz. Elements are made of atoms. When atoms form molecules of compounds, they do so in whole number ratios. And different elements can form different ratios to form different compounds. And then we'll pause. First 8. 9, we have protons. If you're drawing a picture, labeling the nucleus would be a good point. But protons, we're going to put them in the nucleus. Protons is the P+. It's a positive 1 charge. It is a 1 AMU mass. Neutrons, also going in the nucleus with a N0 abbreviation, a no charge or neutral charge, and then also 1 AMU mass. Electrons are going to go floating around, an E- abbreviation, a negative 1 charge, and a negligible mass. Question about picture and whatnot there.
How many points is the picture?
Looks like 4. Protons, neutrons, electrons being in the right place, and then the label of the nucleus is a point. Yep. It's a 4-point picture. 25 is the protons plus the neutrons, or sum of protons and neutrons. But we need either the word sum or a clear addition symbol or something like that going on. So protons plus neutrons makes mass number. 26 is just a proton count. 27 is if an atom gains or loses an electron. So electrons can come or go. If they just say an atom gains electrons, that's like half of a point because that's half of the possibilities. 28 is a series of areas. I could live without the word series if they just say areas. But there are lots of energy levels, so we need some kind of plural indicator there. But it's a series of areas outside the nucleus where the electrons are. Question about scoring anything on that? Okay. So what's up for tonight is some homework. There's a 1L and there's a 7 to 10. So 7 to 10 looks like this. Do we need to turn it all, or is it the whole way? Am I on screen to get to here? Turn. Okay. So what they're going to do is tell you, you have this isotope of, for example, chlorine. You have that isotope of chlorine. Chlorine 35 is going to have a mass pretty close to 35, but not exactly, because these protons and neutrons don't have an exact mass of 1 AMU. There's also a little bit, I think, of mass turning into energy when atoms are formed, that kind of business. But a chlorine 35 should be right around about 35 AMUs. Chlorine 37 is a different isotope. That should be right around 37 AMUs. And then they're going to tell you what percentage each is. So if this is about 75% common, and this isotope is about 24% common, does anybody know how you could run some math here to come up with like a total average of how much mass chlorine in general could be expected to have?
Multiply across in the back here.
Correct. We're going to multiply across. Percentages you want to turn into decimals. How do we turn a percentage into a decimal? Move it to the left twice. So this percentage, make a decimal by moving it left twice. Multiply the mass by how common it is. Multiply the other mass by how common it is. And then what did she say? Add them together. The answer has to be somewhere in what range? between the two. Okay, so if you're averaging 35s and 37s and you're not coming out somewhere between 35 and 37, like something bad has happened, rerun your math. There's a little bit more of the 35, so you'd expect the answer to be a little bit closer to 35. Peeking off of where the book did this, they say this is 35.46, which makes sense to me. It's between 35 and 37, and it's a lot closer to 34. And then the unit on this, as always, would be AMUs. Any kind of mass is going to be AMUs for us at the like molecule atom sort of level. So that's how the math will go. 7 to 10 is the math, and then a 1L is the homework to turn in tomorrow.
I had a question on 7, because I was looking at this earlier. By atomic mass, does it mean mass number or atomic number?
Mass.
Okay.
So we're not doing 4 to 6 yet, just 7 through 10.
5 and 6 is what we're hopefully turning in today, and then 7 to 10 is what we're trying to turn in tomorrow.
I put it on back of this here.
Okay. Question about homework style? Okay, then here's a little bit of info about isotopes other than that, and a preview of upcoming quiz. Tomorrow quiz, I ditched that tell me the 3 proposals that were entirely true, but the quiz still pops from 28 to 29, so there's a little bit of growth there. Reading 4-6 is going to have 2 new points, and they're somewhat concealed. There's nothing in margins, so you'll have to try to just read that and figure out what's going on. But there's 2 points from 4-6 that aren't quite set apart the way they sometimes are. Today, from 2 down, I kept everything except for, as I said, we ditched that question about the 3 proposals. And then there's some change at the top where I'll ask you, what are isotopes? So you'd say they have different mass numbers, but the same atomic numbers. And then I follow that up with, what causes isotopes then? What would make the difference? If you have the same atomic number, but you have different mass numbers, what would account for that?
The difference in neutrons?
Difference in neutrons is correct. So chlorine on the periodic table is number 17. All chlorine is going to have a number 17 there. Which number is this lower number? That's the atomic number. That's counting the protons. And therefore, it's also probably counting the electrons unless they had some strays. Okay, but the difference is this chlorine has what else other than 17 protons and electrons?
20 neutrons.
It has 20 neutrons. Whereas this chlorine has 18 neutrons. That's the difference. If one isotope has a different amount of neutrons, it's just a different type of that element. It's still chlorine, but it's a different kind of chlorine. Then I'll ask you something that was in the reading. What's true about the chemical properties? What's true about the physical properties of isotopes? Anybody have a thought on this?
Sorry.
They've-
Chemical properties are the same. Physical properties
Okay.
are different, potentially. So what would be an example of a chemical property?
What it reacts with.
That would work. Yeah, like what could it do to make a change in color or gas? Burn, for example. So if this kind of chlorine burns, that means that this chlorine burns. If this can form NaCl to be salt to put on your food out of a salt shaker,
That one can.
too. If this one is gonna like kill algae in your pool, then that one's gonna kill algae in your pool. What's a physical property?
Wait, like the mass.
Mass. melting point. So maybe this melts at a certain temperature, and that's gonna melt at a different temperature. This freezes at a certain temperature, that freezes at a different temperature. So the physical properties can be different, but the chemical properties are the same. So that's a question. And then I'll ask you, why are atomic masses not always whole numbers? Because here we found the
Would it be the neutrons?
average. We're finding averages. So averages are very rarely whole numbers. Do we have a pickup?
Yeah.
Get out of jail free card. There you go. So those new questions, here they are again, is what are isotopes? You'd say same atomic number, different mass number. Follow up, what's causing that? You'd say different amounts of neutrons. What's true about chemical properties versus physical properties of isotopes? Chemical are same while physical
Different.
are different. And why are these masses not whole numbers?
Average.
They're averages. And think about your grade. Could your grade average out to be a whole number?
Yeah.
Could. Likelihood?
No.
Pretty low. So possible, but not likely. Question about 4-6 quiz growing to 29. Question about homework, trying to work 7 to 10. Some stuff like was behind me that we did. Did anybody have anything you want to visit on the homework we're turning in today, where we were working primarily 5 and 6, but then some other bits and pieces here or there?
Could you just explain what 6 is asking?
Yeah, so 6, they're wanting you to count the protons. So for 6A, what would the proton count be? Anybody?
11.
11. Then they want you to count the electrons, which would also for now be 11. Sooner or later, some electrons are going to start to travel in our life, and then we'll have to tinker with that number by 1 or 2 or whatever a charge might be. And then do the math to figure out neutron count, which is 12 by subtraction.
So it's, yes, the same as 5.
Same as 5, yeah. They just want you to do a proton, neutron, electron
So
count.
they're trying to ask something different.
No, it's the same. I don't know why they didn't just keep going and make that like G through whatever letter it would be through, but yeah, they're 5 and
it's-
6 are the same.
All of the words are the exact same.
Yeah, that's true. Yeah, why? I mean, why even do that? But I don't know. They do the same thing in this. The 12 and 13, they do the same thing. There's no difference from 12 and 13. I don't know why that's not all number 12. 14 and 15. Why is that just not all number 14? I don't know. Anything else I can do for you, homework-wise, quiz-wise, scoring-wise, anything-wise? That's a wrap.